Hello, my name is Elise Farah, and I will be presenting the project entitled CO2 Proud, which was sponsored by Vinova and done in KTH under the supervision of Eftimios Kantarelis and Lars Peterson in the Chemical Engineering Department. What would you think of feeding ourselves using our own waste? This could be possible if we could convert the CO2 that our activities emit to food industry products. What is more environmental friendly than using the sunlight as plants do? In fact, in Sweden, the amount of CO2 emissions was estimated to be 44.8 million metric tons in 2018, out of which 6.3 million metric tons were emitted from waste to energy plants. This project aims to investigate the endless possibilities for a circular economy by photocatalytically convert CO2 into solar-derived chemicals and fuels. This will facilitate achieving net zero emissions, while independence from fossil-based energy sources will contribute to negate the overall CO2 emissions, reshape the industry, and enable a localized sustainable industrial development with zero CO2 emissions. The photocatalytic reduction of CO2 with water mimics the natural photosynthesis process and is also called artificial photosynthesis. Unfortunately, C1 compounds were mainly reported as products of this reaction, which is far from the C6+ that the carbohydrates consist of. However, the conversion of CO2 to smaller molecules via photocatalytic reduction, followed by chain growth through C-C coupling reactions using already existing thermocatalytic routes, can provide a viable pathway for production of carbohydrates and or their derivatives and precursors. Two possible pathways for the formation of carbohydrates from C1 compounds are the aldol condensation and Formose reaction. Out of the 6.3 million tons of CO2 emitted by the waste-to-energy plants, 1.07 million tons will be photocatalytically converted to methanol, consisting of a 17% conversion. Methanol will then be separated with 100% recovery, and 94% of the produced hydrogen peroxide will be transferred to wastewater treatment plants, increasing the sustainability footprint of the process. For the aldol route, methanol will be converted to ethanol, which will produce acetaldehyde for the production of carbohydrates. As for the Formose route, less steps are required, so it consists of converting the methanol to formaldehyde, which will then give the monosaccharides. Some challenges that this process is facing is the optimization of the photocatalytic conversion of CO2 to methanol, which, as we stated, was low. Moreover, we should improve the photocatalytic conversion of methanol to ethanol and aim to achieve efficient CO2 capture and separation. Thank you.